Let's get started then. Today I'm going to talk a little bit about like improving the storage reliability of Filecoin, specifically in the context of like tuning the termination fees. Uh, so it, I'm going to just rush through the background real quick, but basically the whole context for this was that we observed a sharp increase in the termination fee, in the number of terminations, between July 2022 to March 2023. This was not just in the number of sectors that have been terminating, but also if you look at the fraction, of power that was terminating, like that was also like a spike increase. So we just started a GitHub discussion to track the issue and start to hypothesize, reason for why these terminations must be happening. Sorry. It kind of came down to like two main reasons that we identified. The first one, being decreasing block rewards. So if we kind of like came up with this ROI ratio, which looked at like the two different pathways between how much a storage provider would earn if they chose to terminate this sector versus if they chose to like continue it and earn the rewards. And we kind of like we use projected data to see that, okay, if we look at like different initial seal dates, how does this ratio kind of track? Just as for reference, like if this ratio is greater than 1, it is a sort of like indication that there is a strong incentive to terminate. Anything below 1 means that we're in the sort of safe zone. So this was one reason that we hypothesized. And another one was, was the decreasing of initial pledge. So like there was this strategy, this position strategy of like, pledge arbitrage, where, the pledge at a particular time t is going to be lesser than the initial pledge that was initially locked. So like there was a potential here that you can quickly terminate your sector, and reseal your sector back, so that you can kind of like capture the pledge difference. And when we looked at like the sort of like ROI from that strategy and compared it to the strategy of like no terminations, we once again plotted this over time, and we saw like where this ratio lies in comparison to the y is equal to 1 line. So yeah, these sort of indicated that according to the present like fee policy, so there was a reason to terminate sectors, and so like we kind of like started thinking about like, okay, if we were to like update the fee to kind of like combat this, like what would that look like? So the first step to that was to kind of like understand the current fee structure, break it down, decompose it into like the various parts that we have, understood why the certain parameters like the weighting factor and things like that was sort of set to the values that it initially was, and I guess like on speaking to like stakeholders like block science and kind of like diving through the documents a little deeper, we found out the justification was this for like setting the policy that it currently is right now was that for a sector of 6 months, they wanted to have value the termination fee such that it's like half the lifetime worth of block rewards. So like this kind of like made us question what this would mean when, okay, like at that time, like this was how the structure was sort of like built in, assuming like a maximum duration of 6 months. But how should this policy change when the maximum sector duration is increased to 1.5 years or 3.5 years? And so that was the sort of like line of thinking that we had, and based on that, we had come up with proposals for like potential changes that we could introduce to the termination fee policy, such that it would like scale with sector duration, so this was like one proposal that we put forth to see like how the community responds to it. We further looked into like how this would change the incentives to terminate, and we noticed that, okay, like with the new termination fee policy, it's not so stringent that there is no way out for like SPs who are kind of like unprofitable, but at the same time like it pulls these curves below the y is equal to 1 line, which means that, okay, like it's sort of like it's sort of like a step in the right direction towards like disincentivizing terminations and things like that. We further built a statistical model to capture the causal relationships between the data. Okay, I think this should be displaying something. but I don't know why it's not displaying anything. But it's visible in my laptop screen. But basically, like, yeah, we built a statistical model, and we've included, like, so it would basically capture the relationships between, like, the daily terminating fraction, as well as factors such as termination fees, Filecoin price, and we also, like, introduced this, like, Gaussian random walk to model other, like, unpredictable exogenous factors such as, like, changing legal regulations, which might affect termination fee. Now, the reason why I rushed through this part so much was that when we went back to the GitHub discussion and we looked at, like, what the community was responding, we realized that this is not what the community wants. So our line of thinking happened to be in a completely different page from the line of thinking that most SPs or, like, most even, like, core devs like we're thinking about. So what was the status quo in terms of the discussion about, like a changing termination fee structure? We noticed that there was divergent views from the GitHub discussion. So there's one school of thought that we need to increase the termination fee fee penalty to disincentivize SPs from leaving the network, which was sort of like along the lines of our thinking. But there was also, like, a significant portion of the community which was against this, and they wanted to decrease the termination penalty to values even such as like a zero termination fee penalty, just to reduce the risk for SPs and lower the entry threshold for them. But so there was a lot of, like, hypothesizing that was happening in this thread. There were a lot of ideas put forth and a lot of people saying, hey, if we do this, this is how the network's going to turn out. But the thing that was really missing was a quantitative approach to actually test these hypotheses. Like, this was just intuition that people were using to kind of, like, say that, okay, this is what we should do. But there was no, like, actual way to test whether or not like changing the policy in a certain way would actually affect key network KPIs such as, like, terminations or, like, QAP and stuff like that. So, like, what was basically missing was this quantitative approach to hypothesis testing for all the ideas that were put forward in this thread. And that is where we decided, okay, maybe we should, like, systematically work through a way to actually show the community that, okay, like, if we implement X policy, this is the sort of outcome, and it will help us also kind of, like, understand what direction we should go towards, and which is why we decided to use agent-based modeling and an agent-based model approach to kind of, like, work through this. So just a quick precursor on what the agent-based modeling framework is. So, like, an ABM can basically be decomposed into, like, two main components. The first one being the environment, and the second one being the agents. So the environment is basically what implements the cryptoeconomic mechanisms of Filecoin, and through the agents we can kind of, like, model SP behavior. So suppose we say rational behavior is for an SP to kind of, like, terminate power when the block reward significantly decreases. If we can, like, so through to the power of, like, Python code, we can actually encode that behavior through agents. And this approach is very useful for policy selection because we can model what a rational agent would do. We can encode the environment specifications and also, like, encode the different policies we wish to compare. And once we execute the simulation, we can kind of, like, work through and see which policy leads to most optimal outcomes. And so that's what we decided to go forward with. And an important note here is that through this approach, we're really not making any predictions, to what the network KPIs under these policies would look like. We are not in any way saying that, okay, if we implement this policy, this is what the QAP would look like, etc. Instead, we just want to test, different policies in the simulated environment to kind of find the optimal one. And the argument here is that it would also perform well on mainnet. So yeah, just a quick note: the simulated network KPIs can differ from what is observed in reality. So better outcome can be, for instance, like lower terminations. It can also be in higher QAP. So I'll get to this later, but we basically track four things. The first one being QAP, the second one being the daily power onboarded, the daily power renewed, and the fourth one being the daily power terminated. So yeah, so how exactly did we encode the sort of behavior of SPs? So if you look at onboarding and renewals, so the way we kind of like encoded or the rules that we asked the agent to follow, before the agent decides whether or not like power should be onboarded or renewed, is by using the per sector forecast provided by the network. And once we use the per sector forecast, the agent would then come up with values for the penalty to reward ratio of onboarding sectors for various sector durations. So this would essentially mean that like the agent would project the rewards from onboarding like an additional sector and compare that to the termination fee. And if the expected rewards to the termination fee kind of like exceeds a certain configured threshold, then we say that okay, like the agent is going to onboard a configured amount of power. And we follow a similar like sort of like rule for renewals as well.
How did you select that pre-configured value?
The threshold or the configured amount of power. The threshold, we basically looked at like data. So what we did is, for instance, when we say, suppose in our experimental setup, the max power that's going to be onboarded is going to be like 1 petabyte per agent, and we look at like how many agents are there in the network. So what we did is we looked at okay, like ideally if like all agents were to onboard like power, this would be like the total amount of like QAP that's going to be onboarded that day, and we compared it to like real statistical data to see that okay, like if the penalty to like rewards ratio for that day is so we basically like look at what the correlation between the penalty to rewards ratio in reality was to the amount of QAP that was onboarded historically, and we kind of used that to come up with like a reasonable estimate to what this this threshold would be. But in an ideal case, what we would propose doing is to extend our simulations in such a way that we actually encode this parameter as a way to like track the risk aversion of SPs, to say that okay, like ones with like lower threshold would basically mean that the SP is more risk averse and willing to take like bigger bets, or sorry, less risk averse and willing to take bigger bets, and a higher threshold would mean that they're just little more cautious. And so so one extension to our experiments could be that we could track like how the results go for like different values of this configurable threshold. But for now we just used historical data to come up with like a reasonable estimate for that. So in terms of like the specifications of the agent when it comes to terminations, we had basically like 3 sort of agents, and they can terminate power in like the following way. One type of agent is just the passively terminating behavior, where we just select random dates and we just say that okay, under any circumstance these agents are going to like terminate their power, and this is to kind of like encode agents that passively terminate power because of like this can be like hardware failures or like loss of private key and things which are really not under their control. One more sort of like behavior that we sort of encode is the optimistic behavior, because because we know that there are some SPs who really like they really believe in the future of Filecoin, and so they do not terminate any power because of confidence they have in the mission and the promise of a much greater future ROI. But then in the third category is where the rational agent sort of like falls under. So like this is the type of agent that basically forecasts the ROI from keeping the sector alive for the entirety of its duration, and also the ROI from terminating the sectors and selling their hardware at a salvage value. And depending on which pathway yields better results, these agents basically decide whether or not they want to terminate a configured amount of power. So how exactly is this ROI calculated? So like if you look at the utility from termination, it's basically going to be nothing but the salvage value of the sector minus the termination fee times the initial price of Filecoin at the time of termination. And for the utility of no terminations, it will just be like P2, which is going to be like a price of fill at the time of sector expiry times the expected block rewards. And so in essence, if this like U termination is going to be greater than U no termination, then the agent is basically going to terminate a configured amount of power from the system. And we kind of like ran the experiments assuming different distributions of like of P1 and P2, just to see like how it would track based on the Filecoin price as well. Okay, so this is how we set up the experiment. This is how we configure the agent behavior, and now let's move to the results. So here are the simulations that we kind of ran for a network with an equal distribution of agents that believe that the future Filecoin price would be $0.1, $1, $10, and $100. So in the left, we basically like not the left per se, but yeah, we basically tracked this for like 3 different policies. The first being the zero termination fee policy that many people were advocating for. The second one is the current termination fee policy, which is currently implemented, and the third one being the increased termination fee policy that we put forth earlier and suggested to the community. So I think from the graphs you can basically figure out here that the main key takeaway. Okay, so yeah, I know these charts might not be too readable. So like we've also like included like the summary statistics from all our experiments for like the QAP, the daily onboarding, daily renewals, and daily terminations. But the TLDR here is that there is no free lunch. So if you have an increased termination fee penalty, yes, the daily onboarding rate and the daily renewal rate is going to take a hit. And this consequently also affects the daily QAP in such a way that the mean value goes like considerably below the case where like the termination fee policy remains the same. And at the same time, if you have like a zero termination fee policy or a current termination fee policy, the sort of like amount of network termination still continues to be like as high as it is now. But if we have the increased termination fee policy, like this value drops like significantly below what we see in the cases of the other 2 policies. Okay, so keeping all these in mind, I guess the main point of this talk is to raise 2 points of discussion. The first point being, okay, now that we know there is no free lunch, that there are these sort of like 2 things that we need to optimize for, and there is no single pathway in which we can optimize for both, should we implement a different policy for different types of SPs? So the trade-off here is between sustained QAP growth and robust storage reliability. So what if we give the option for risk-averse SPs to kind of like choose to contribute storage power to the network as CC miners for a low risk, and this can be encoded by a near zero or zero termination fee policy. This will basically allow them to enter and exit the network as they pleased based on the current network conditions. But for those SPs who desire to take on the risk of like storing actual client data, such as like fill plus sectors or deal sectors, if they decide to do so, then we need to really optimize for a great client experience. And the only way we can do that is to provide like stronger guarantees for data storage. So for these SPs alone, like what if we have an increased termination fee policy such that it sort of like gives higher guarantees that the data is going to be stored and it's not going to be terminated from the network. So this is the one first point of like open discussion, or like rather like first point that we want to put forth. And the second, I guess, like more long-term point that we want to put forth, and credits to like Nicola for synthesizing this idea. It was actually like came up when we had a discussion with him based on this. Is should we rethink how we how we formalize storage reliability? So the key question here is more with potentially higher variance, better, or worse than less with higher assurance. So what this basically boils down to is, should we think of storage reliability as, okay, encouraging, storing a lesser number of data copies with a greater guarantee of storage to these like few SPs that do desire to store them, or should we also, or should we instead encourage like storing a greater number of like data copies with a weaker guarantee of storage, so that it doesn't matter like if a few SPs kind of like leave the network, because they're anyway going to be like multiple copies of the same data being stored across the network. So this is a more like long-term discussion, but yeah, these are the 2 like open points and open questions that we want to put forth based on the results of all our analysis. That's it from me, but yeah, happy to like answer any questions or like have any discussions now.